The domain name system, or DNS, acts as the Internet's address book, mapping human-readable domain names to numerical IP addresses. Just as people have multiple identifiers like names and passport numbers, Internet hosts have both IP addresses, used by machines, and domain names, which are easier for humans to remember. When a user enters a domain name, the DNS system queries servers to find the corresponding IP address, allowing seamless access to websites. This service eliminates the need to memorize IP addresses and enables efficient Internet navigation by resolving domain names dynamically as needed. DNS is a distributed database organized in a hierarchical structure of name servers. It operates as an application layer protocol, allowing hosts to communicate with name servers to resolve domain names into IP addresses. This system is a core function of the Internet, enabling seamless access to websites without requiring users to remember numerical IP addresses. The complexity of DNS is managed at the network's edge, where queries are sent to multiple servers until the correct IP address is found. This hierarchical and distributed approach ensures scalability, efficiency, and reliability in name resolution. DNS performs several essential functions, such as translating host names to IP addresses, managing host aliases, and supporting mail server aliasing. It also facilitates load distribution by mapping multiple IP addresses to a single domain name, often used for replicated web servers. However, centralizing DNS would not be scalable due to several factors, such as high traffic volume, the complexity of maintaining a distant centralized database, and the risk of a single point of failure. Additionally, regular maintenance would be challenging. Therefore, DNS is decentralized, allowing for efficient and resilient resolution across the global network. DNS operates as a distributed hierarchical database that resolves domain names into IP addresses. When a client requests the IP address for a website like www.amazon.com, the process follows a sequence of queries. The client first contacts a root DNS server, which directs it to the relevant top-level domain, TLD server, such as the .com DNS server. This server then provides the location of the authoritative DNS server for Amazon.com, which ultimately returns the IP address. This hierarchical approach ensures efficient resolution while distributing the workload across multiple servers, making DNS scalable and resilient to failures. The DNS system follows a hierarchical structure with nodes labeled at different levels. At the top is the root DNS server, which manages all top-level domain, or TLD, servers such as .com, .org, .edu, and country-specific domains like .uk or .fr. Each TLD server oversees authoritative DNS servers for domains registered under it. This structure allows DNS queries to be efficiently resolved in a step-by-step manner, reducing the burden on any single server. By distributing name resolution across multiple layers, DNS ensures scalability, redundancy, and fast lookups across the Internet. DNS follows a hierarchical structure where domain names are organized as a sequence of labels extending up to the root. This structure is represented as a tree with two main types of top-level domains: generic TLDs, GTLDs, such as .com, .edu, .org, and country code TLDs, CCTLDs, such as .us, .uk, .jp, .it. Below the TLDs, domain names further branch into subdomains and specific hosts. This hierarchical design enables efficient domain name resolution by systematically directing queries from root servers to TLD servers, and then to authoritative name servers managing individual domains. Root servers are the top-level servers in the DNS hierarchy, and there are only 13 root server clusters worldwide. Each root server can handle queries for any domain, but they don't store the actual mappings. Instead, they direct queries to the relevant top-level domain servers. Root servers are highly distributed, with many replicas to ensure reliability and reduce latency. Top-level domain servers manage the domain names for specific TLDs like .com, .edu, or country codes like .uk. Beneath them are authoritative DNS servers, which provide the actual IP address for a domain name. For example, if you're looking for www.amazon.com, the TLD server for .com will direct you to Amazon's authoritative server, which will then provide the IP address for their website. Every network typically has a local DNS server, which is responsible for forwarding DNS queries from users to the global DNS hierarchy. The local DNS server can cache recent DNS query results, which helps reduce the load on the rest of the DNS system and speeds up response times for frequently accessed domains. However, because these cached entries can become outdated, the server periodically refreshes its cache. In an iterative query, the client's local DNS server handles the query by asking each level of the DNS hierarchy for information, starting with the root server. Each server responds by directing the local DNS server to the next one in the chain until the query reaches the authoritative DNS server, which returns the final IP address to the client. In a recursive query, the local DNS server asks the next server in the hierarchy to completely resolve the domain name on its behalf. This shifts the burden of name resolution onto the contacted DNS server. While this reduces the workload on the local DNS server, it increases the load on higher level servers, which need to perform more of the resolution process themselves. DNS caching helps improve performance by storing recent domain-to-IP mappings for a specified time, known as time to live, TTL. However, cached entries can become outdated if the domain's IP address changes before the TTL expires. DNS servers also support update notify mechanisms that allow authoritative servers to notify local servers of changes to domain name mappings, ensuring that cached information remains current. The Internet Assigned Numbers Authority, IANA, is responsible for managing the global domain name system. There are several types of top-level domains, including country code TLDs like .uk or .jp, and generic TLDs like .com, .edu, and .org. Over time, new TLDs have been introduced to accommodate the growing number of websites and domains on the Internet. In addition to the traditional top-level domains, newer TLDs have been introduced by ICANN, including .biz, .info, and .name. These new domains help to address the growing demand for unique domain names. More recently, we've seen the introduction of geographic TLDs like .nyc, .berlin, and .london, as well as branded TLDs like .apple and .google, which allow companies to use their names as domain extensions.